Okay, this is the continuation of the last video. I was talking about uh, the fourth point. Electrostatic potential is constant throughout the volume of the conductor, and I saw that the charges resides on the surface of the conductor. That means at the surface, the value of the potential is charge divided by 4 pi epsilon naught 0. Now, if you were to bring 1 unit positive charge from surface to any point inside the conductor, then your work will be 0. Why your work will be 0? Because inside the conductor there is no any electric field. Therefore, therefore you will do work without any influence of the electric field. So your work will be 0 because there is not anything inside the conductor, so your work must be 0. But from the definition of work done, work can also be written as the difference in the electrostatic potential of 2 points. So suppose P point is the point inside the conductor and Q point is on the surface, then your work will be equals to Vp minus Vq. But at the surface, that is at point Q, your potential is Vq, which is Q divided by 4 pi epsilon naught r. But but your work done should be 0. That means your Vp should also be equals to Q divided by 4 pi epsilon naught r, because your work should be 0. That means at every point inside the conductor, your potential will be equals to the potential at the surface, because your work done should be 0 in bringing a unit positive charge from surface to any point inside the conductor, because field is 0 there. That means inside the conductor, the electrostatic potential matches with what at the surface. So this is our fourth point. So now fifth point is electric field at the surface of a charged conductor is E is equals to sigma divided by epsilon 0, and its direction is normal to the surface. So like I did it before, but my phone slept. That's why I couldn't capture this lesson. So I'm going to taught you now. So if I have a conductor, this one, if I have a conductor, at the surface, the charge resides on the surface, and electric field is normal to the surface. Now if I consider a Gaussian surface enclosing some charges, and electric field is normal to the surface, and it is again normal to the Gaussian surface also. It is normal to the Gaussian surface also. And the cross-sectional area of the Gaussian surface is delta S, and whose direction is again normal to the surface itself, which is given by n cap. So flux through this Gaussian surface will be equals to phi is equals to E dot del S. Now E and del S have same direction. E is also in this direction. Direction of del S is also in this direction. So flux will be just E del S, which I have given equation 1. Now from the Gauss's law, the flux must be equals to charge enclosed by the surface divided by permittivity, free space permittivity. Now what is the charge enclosed by this Gaussian surface? We can write it in terms of the surface charge density. If sigma is the surface charge density, then cross-sectional area multiplied by the surface charge density will give me the charge enclosed by this Gaussian surface. So charge enclosed by the Gaussian surface will be equals to charge density into the surface, Gaussian surface. So charge enclosed is sigma del S. So in place of Q you can write sigma del S. So phi will be equals to sigma del S by epsilon 0, which is given equation number 2. Now this flux must be equals to this flux. So this flux E del S must be equals to this one. So del S gets cancelled. So E will be equals to sigma by epsilon 0. So E will be equals to sigma by epsilon 0, which we were to prove. And the direction of E is given by the normal direction, which is perpendicular to the surface itself. This one. Now our sixth point is electrostatic shielding. Electrostatic shielding, like, which is very simple. So now if you have a conductor, if I have a conductor, and we know inside the conductor electric field is 0. Now if you have some devices, if you have some electronic devices which you want to keep safe, or you want to protect it from the electric field, then what you will do? You will keep that sensitive device inside the conductor. Why? Because inside the conductor is electric field is zero. So when you keep your sensitive device inside the conductor, then you will make it safe from the electric field. There is no electric field to influence this device. So this conductor is somewhat working as a shielding, like it is shielding our devices uh, from the electric field. So this phenomena is electrostatic shielding. So for electrostatic shielding, you can use a conductor to protect any devices from the stray electric field. Okay, so this is it for today. So if you have any doubt or questions, queries about this discussion, you can raise in WhatsApp. Okay, thank you.